Okay, so today we'll discuss about the capacitor. Okay, so this is our class 3 of the electrostatics module. Now we'll discuss about the capacitor. Fine. So what is capacitor? So capacitor is the device that can store the energy in form of the electric charge. The internal structure of the capacitor will be this. These are the two plates. These are the two plates and joining with the battery. So if we complete the circuit, then this plate will be occupy the positive charge and this will occupy the negative charge. Fine. The capacitor is the machine. Capacitor is the device which can store the electric charge. Fine. Which can store the electric charge. So this is the voltage V. So now if we increase the voltage, then the charge Q will be increased also. Q will be increased. So we can write Q is proportional to V. We can write. So if we put the equal and remove the proportional sign, Q is equals to C into V. C is the constant, proportional constant, and C is known as the capacitance. Now what is capacitance? Capacitance is the ability of the capacitor. Capacitance is the ability of the capacitor to store the charge. Okay. So capacitance is the ability of the capacitor to store the charge. Fine. Now see, Q is equals to C into V and C is equals to Q by V. C is the capacitance. Now can you see the units of capacitance will be what? See, the SI unit will be what? SI unit will be farad and CGS unit will be state farad. Okay. Now see, 1 farad it is equals to 1 coulomb by 1 volt, because Q by V means charge by voltage. So 1 coulomb by 1 volt. So we can write 1 coulomb. If we change 1 coulomb into CGS, then we can write 3 into 10 to the power 9 state coulomb, and 1 volt is equals to in CGS 1 by 300 state volt. Fine. Now see, 3 state coulomb by state volt is what? State farad. So 9 into 10 to the power 11. So 1 farad is equals to 9 into 10 to the power 11 state farad. Okay, this is the conversion of CGS to SI. Fine. Now we'll go to the capacitance of the parallel plate capacitor. Okay, so put the heading parallel plate capacitor. Okay, so this is the one plate and this is another plate. Okay, so this is the positive charge plate and this is the negative charge plate. Fine. Now the vacuum is in between the plates. Now another thing is this is one plate, this is one plate. If we put some insulating material between the plates, this is known as the dielectric. Okay, if we put some insulating material between the two parallel plates, this is known as the dielectric. Okay, In this case, we haven't put any dielectric, so we can say that there are vacuum in the between the two plates. Fine, fine. Now see the electric electric field intensity. The electric field intensity of the two plates will be how much? The electric field intensity between two plates will be how much? E is equals to how much? Sigma by epsilon naught, as you studied earlier. Sigma by epsilon naught. Now, what is sigma? Sigma is the surface charge density. Sigma is the surface charge density. This is the surface of total charge Q. Q is distributed. Okay. So, if someone tell you to find the charge per unit area, then we will find the sigma. This is the charge per unit area, which is known as the surface charge density, which is equals to Q by area. So we can write sigma is equals to total charge by area. In this case, total charge is Q. Fine. Total charge is Q. So we can write this is the plus sigma, this is the minus sigma. Fine. Now, just put the value of sigma. So E will be 1 by epsilon naught Q by A. Okay. So this is denoted as number 1 equation. Now see, since the electric intensity is uniform, the electric intensity is uniform between the two parallel plates, plus to minus. Electric intensity is uniform. So we can write, and the space between them is D. So we can write the voltage difference. Voltage difference will be how much? Voltage difference V will be what? E into D. E into D. Now from 1, we can no, sorry. Now the formula of capacitance, which is C is equals to Q by V. Q by V. Now just put the V. V is E into D and Q from 1. What? E is equals to 1 by epsilon naught Q by A. Just find out the value of Q. Q will be what? E into epsilon naught into A. Just put it into this. So Q is E into epsilon naught into A. E cancel. Epsilon naught A by D is C. So in case of parallel plate capacitor, the capacitance will be epsilon naught A into D. If we put any dielectric between the two plates whose dielectric constant is K, then the capacitance will be K into epsilon naught A by D. Fine. Now we have to find the force between the plates, parallel plates. Okay. So this is positive plate, this is negative plate, this is negative plate. So this is plus sigma, this is minus sigma. Fine. The electric field due to positive plate will be how much? The total electric field is what? Sigma by epsilon naught. So the electric field due to the positive field will be what? Sigma by what? Sigma by 2 epsilon naught. Fine. Then force is how much? We know the force is how much? Q into E. So Q sigma by 2 epsilon naught will be the force. Okay. So force will be the Q sigma by 2 epsilon naught. Fine. If the E is the electric field, E is the total electric field, E is the total electric field, then the force will be what? See, E is the total electric field. Then sigma will be what? Let me write in this pen. Sigma will be what? Sigma will be E into epsilon naught. E into epsilon naught. Just put it here. Is equals to Q by 2 epsilon naught into E into epsilon naught. Epsilon naught is cancelled. Q E by 2. So we can write force is equals to half into Q into E. So this is the equation of force of the parallel plate capacitor. Okay. Now see again we can write force is equals to half into QE. As per this, half into QE. Fine. Just put the Q and put the value of E. What is the value of E? Value of E is sigma by epsilon naught. Just put the sigma by epsilon naught. Then half into Q by epsilon naught, and sigma is what? Q by A. Just put the Q by A. Now see, half into Q square by epsilon naught into A. This is the another format of force. Clear? This is the another format of force. F is equals to half QE and F is equals to Q square by 2 epsilon naught A. Fine? Fine? Now the next topic is capacitance of an isolated spherical conductor. Capacitance of an isolated spherical conductor. It is easy. See, this is the spherical conductor. This is the charge and radius is R. Fine, radius is R. Now say the potential at the surface of the sphere. Potential at the surface of the sphere is denoted by what? Potential at the surface of the sphere V is equals to what? 1 by 4 pi epsilon naught Q by R. Correct? And the capacitance C will be what? Q by V. Just put the V. Q by 1 by 4 pi epsilon naught Q by R. Q will be cancelled and the C will be 4 pi epsilon naught R will be the capacitance. Fine. For the isolated sphere conductor, the capacitance will be 4 pi epsilon naught R. Fine. Easy. Now the next topic is the combination of capacitor. There are two types of combinations of the capacitor, just like the resistor. One is parallel, one is series. In case of parallel, how will be the capacitor arranges? The capacitor will be arranged like this, right? So this is C1, C2, C3, right? We denote the capacitor like this. Okay, this is the capacitor. Okay, and the series, how will we denote? Will be denote like this. C1, C2, C3. Just remember, this is very easy. Just remember that. Just remember this. In case of parallel combination, the equivalent, if the equivalent resistance, if the equivalent capacitance is Cp, then Cp will be C1 plus C2 plus C3 plus ... How many the capacitors are. Okay. In case of series capacitor, if the equivalent capacitor is Cs, then Cs is will be 1 by Cs is will be 1 by C1 plus 1 by C2 plus 1 by C3 plus dot 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 how many the capacitors are there. So what we have to remember? We have to remember in case of capacitor, just oppose the what? Just oppose the yeah, resistor combination. Like in case of resistor combination, if the series are there, we just plus R1 plus R2 plus R3. In case of the parallel combination of the parallel combination of the uh, in case of the parallel combination of the resistors, then we put the 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. In case of the capacitor, just opposite, just put the opposite formula for the capacitor. Okay. In case of the parallel combination, just Cp is equals to C1 plus C2 plus C3. In case of the series combination, Cs will be the C1 by Cs is equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus dot 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 how many the capacitors are there. And the last topic is the energy stored in the charge capacitor. We have already discussed that the a capacitor can store the energy, store the charge, but how much energy, how much charge can a capacitor store? So this is the next heading. It is the energy stored in a charged capacitor. Okay. So this is the capacitor and this is the positive plate and this is the negative plate. So let's draw in a broader way. This is the capacitor. This is the uh, positive charge plate. This is the negative charge plate. If we okay, and the potential difference will be the V, and the potential difference will be the V. Now see, for a small charge of dq, if we put the small charge from positive plate to negative plate, how much work done we have to done? We have to done the dw work done, which is equals to V into dq. Fine, fine, and also we note that the q is equals to c into v, which is the voltage. We already know that. So if we put the v, then q by c will be there. So q by c into dq will be the value of dw. So we have to do the work done of dw to change the dq from plus positive plate to the negative plate. Okay, so now say the total work done will be how much? Total work done will be how much? Total work done will be just integrate w is integration of dw, which is equals to integration of q by c into dq. Now say the what will be the integration limit? The integration limit will be 0 to q. Means for this capacitor, the total charge is capital Q. So the integration will be 0 to capital Q. Correct? Correct? Just 1 by C will be the outside of the integration because capacitance is constant for any particular capacitor. So 0 to Q, Q dQ. Fun? Fun? Just do the integration. Q square by 2, limit will be 0 to positive Q. Then 1 by C is equals to what? Q square by 2 minus 0. 0 square by 2 minus means 0. So Q square by to C will be the what? Work done. So this work done is stored as the electrostatic potential energy inside the capacitor. Right. This work done is stored inside the capacitor as a electrostatic potential energy. So we can say the energy will be how much? Energy will be how much? Q square by 2C. Q square by 2C. Fine. Now this is the one equation of energy. Now see. Now see. U is what? U is U is what? Q square by 2C. Fine. And Q is equals to C into V. So we can write C square V square by 2C. 1C cancel CV square by 2, which is equals to U is equals to half into CV square. This is the another equation. Now the next will be U is equals to half into CV square as per this. Fine. And see, half into CV into V. We can write V square as V into V, right? So half into CV means what? Q into V. So we can also write U is equals to half into Q into V. This is the another equation. So we already got the three equations of energy of the capacitor. One is U is equals to Q by 2C, U is equals to half CV square, U is equals to half QV square. Okay. So till now we have discussed the main concepts of capacitor. In the next class, maybe we will see some numericals problems for the electrostatics topic. So thank you. Jai Hind.